Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL May 2021 paper 2 time zone 1 past paper and we are solving one question each day. So today we will be solving question 2 and you will be getting the links to all the previously solved questions in the description area in the playlist. So without any further delay, let us start with our today's session. We start with question 2. It contains 6 marks and it says a company produces bags of sugar whose masses in grams can be modeled by a normal distribution with mean 1000 and standard deviation 3.5. A bag of sugar is rejected for sale if its mass is less than 995 grams. Okay. So part A says find the probability that a bag selected at random is rejected. That means its mass will be less than 995 grams. Fine. So we start with the part A. Let X be the mass of a bag and this X will be a normal distribution because they have said masses can be modeled by a normal distribution. So X will be a normal distribution variable. And the mean is 1000 and standard deviation is 3.5. So the variance will be 3.5 squared. And we need to find the probability that the selected bag at random, the bag that has been selected at random should be rejected. That means its mass should be less than 995 grams. So we need to find the probability where X is less than 995. So we'll be using the calculator menu and statistics, you may take the probability as well. You come to distribution and then it will be normal CDF less than 995 grams. So the maximum mass will be 995. Therefore, we keep the lower bound as it is and we write the upper bound as 995. And the mean is 1000 and the standard deviation, mean is 1000 and the standard deviation is 3.5. Okay. So this is 0.0766 up to 3 significant figures. 0.0766. Okay, and let me write over here as well. 0.0766. Okay, and let us write the using norm CDF and what are the values? Negative 9 times 10 to the power of 999. And then comma 995. Then 1000. Then 3.5. Then 1000. Then 3.5. Okay. So we are done with the subpart A, coming to subpart B. Estimate the number of bags which will be rejected from a random sample of 100 bags. Contains just 1 mark. So if a bag is selected, if a bag is rather chosen at random from a sample of 100 bags, it can be accepted or it can be rejected. There are only two possibilities. If its mass is above 995 grams, it will be accepted. And if its mass is less than 995, it will be rejected. So we are having only two possible outcomes. And the probability of a bag getting rejected is 0.0766 that we have found out just now in the previous subpart, in subpart E. And that is also fixed. It is not that it is dependent on which bag we are testing. It is the same for the first bag. The probability is the same for the first bag. The probability is the same. The probability of rejection, I mean, is the same for the 100th bag as well. The probability is not dependent on which bag we are testing. Okay, so it is independent of the bag number. The probability is the same for every bag. There are only two possible outcomes, and the number of trials is fixed. We will be testing, we have just taken 100 bags, and we will be testing, and they are saying, they are asking us to estimate approximately on an average how many bags out of those 100 bags will be rejected because of having a mass less than 995 grams. Okay, this is the question. So we are having a fixed number of trials. We are having only two possible outcomes, either rejection or acceptance, and the probability is fixed. The probability of rejection or probability of acceptance is fixed. Therefore, it is a case of a binomial distribution. Okay? Let y be the number of bags rejected. From the 100 bags. So y will be a binomial distribution variable where n is 100 and the probability of success is probability of rejection. So this is 0.0766. Okay. And now we have to get the expected number of bags to be rejected from these 100 bags. So it will be expected value of y. This will be equal to NP. N is equal to 100. P is equal to 0.0766, which is equal to 7.66. So you may keep the answer as 7.66 bags because it is the estimated value. It is not that you have to give a whole number in order to make your answer correct. Expected value can remain as 7.6. Or else you may say it is obviously more than 7 bags. So you may write your answer as 8 bags. You cannot obviously reject 7.66 bags, but the expected value can be a decimal number. Even if you give 7.66, you will not be losing marks. or else you give your answer as 8 bags. Okay. So 8 bags will be the answer to the subpart B. Subpart C. Given that a bag is not rejected, given means it is a case of a conditional probability. Given that a bag is not rejected, that means it has a mass greater than 995 grams. Find the probability that it has a mass greater than 1005 grams. Okay. It is a case of a conditional probability. So probability that the mass of the bag is more than 1005 grams, given that the mass of the bag is not less than 995 grams. That means X is more than 1995 grams. So this will be equal to according to the formula, this is X greater than 1005 grams and X greater than 995 grams. Obviously, a bag which is having a mass more than 1005 grams will be having a mass more than 995 grams. I have written the formula. If you have a conditional probability, the numerator will be the intersection of both the conditions and the denominator will be the probability. When the numerator is the probability of the both the conditions being satisfied, and the denominator will be the condition is getting satisfied. So this is this. Okay. And obviously for the numerator, we will be finding the probability where the mass of the bag is more than 1005 grams because it automatically implies that it is having a mass greater than 995 grams. Okay. So, and what about the denominator? The denominator, it is, see over here, P of X less than 995 is 0.0766, but let me take some more digits, some more numbers, not up to 3 significant figures. I would suggest you to take more number of digits in intermediate calculations. For your final answer, always you have to give your answer up to 3 significant figures, but not in your in-between calculations. So I'll be taking 0.076564. Okay. And I have to get P of X greater than 995. And we know the sum total of all the probabilities is equal to 1. So X probability of X greater than 995 plus the probability of X less than 995 should be equal to 1. Therefore, P of X greater than 995 should be equal to 1 minus P of X less than 995, which is equal to 1 minus 0.076564, 0.076564, and let us find this. 1 minus the answer, enter. It is 0.923436. 0.923436. Okay. So we have found the value of the denominator, the probability of the denominator. Now we get the probability of the numerator. X should be more than 1005 grams, and the mean and the standard deviation, they will be the same. The mean is 1000, the standard deviation is 3.5. So we come over here, menu, statistics, distribution, normal distribution. This time it should be more than 1005 grams, so the lower bound should be 1005. And the upper bound, let me write a series of nines. And mu is 1000 and standard deviation is 3.5. Okay. It is 0.076564. Okay, okay. See, the probability of a bag weighing less than 995 is the same as the probability of a bag weighing more than 1005 grams because of the symmetrical nature of the normal distribution curve. Okay, 995 is 5 units to the left of 1000. 1000 is the mean, and 1005 is 5 units to the right of 1000. Therefore, the probability of masses of bags less than 995 should be equal to the probability of masses of bags more than 1005 grams. Okay. So 0.076564. So therefore, let us write the conditional probability over here once more. Is equal to 0.076564 over 0.923436 is equal to the numerator is this one. So this is the answer, and the denominator will be 0.923436. 0.923436. Okay, fine. 0.0829. Okay, up to 3 significant figures, so it will be 0.0829. 0.0829. Okay. So the answer for subpart C is 0.0829. Okay. So students, we have completely answered this question number 2. We have answered all the 3 subparts of question number 2. So we meet again tomorrow with question number 3. We will be solving question number 3 tomorrow. And thank you for staying with me till the end. And I have decided to conduct group online tutoring, math tutoring sessions from the month of July for IB Math A, SL and HL students. And if you are interested in joining my classes, then you may contact me by mailing me. You are getting the email ID over here, or my WhatsApp number is over here, somewhere over here. You may text me. You may contact me if you are interested in joining my classes. Okay. So we meet again tomorrow. Till then, bye.